Our today's lesson will be based on two important concepts from the chapter of electricity, namely potential difference, abbreviated as PD, and electromotive force, abbreviated as EMF. At the end of the lesson, you should be able to, firstly, understand what is potential difference, secondly, understand what is electromotive force, thirdly, understand the difference between them. Potential difference is quite an abstract concept in electricity. To understand the concept, we will consider a gravitational analogy. We start by looking at this waterfall, which you probably have had the opportunity of admiring during one of your school outings. My question is, why does the water fall from the top to the river below? In other words, why does water fall from point A to point B? The obvious reason is the water has more potential energy at A and less potential energy at B. In other words, there is a difference in potential energy between points A and B. We may conclude that water falls from a point of higher potential energy to a point of lower potential energy. Or water falls when there is a gravitational potential difference. Similarly, if the tap is opened, water flows from tank A to tank B. We are now in a position to understand potential difference. We return to our electrical circuit. The positive terminal of the battery is on the left. This means that the left side of the circuit is at a higher electric potential. The negative terminal of the battery is on the right. This means that the right side of the circuit is at a lower electrical potential. Consequently, current flows through the bulb from left to right, that is, from point P to point Q. We now look at the same circuit from an energy perspective. When a unit charge passes between the 2 points containing the bulb, electrical energy is converted to heat energy and light energy. The work done to bring about this energy transformation is called potential difference. The potential difference between 2 points in a circuit is defined as the work done when 1 coulomb of charge passes between the 2 points. Mathematically speaking, Q is the charge which flows between the 2 points. W is the work done to move the charge Q between the 2 points. V is the potential difference between the 2 points. The SI unit for potential difference is volt, but from this equation, we see that another unit for volt is joule per coulomb because W is in joule and Q is in coulomb. So, we have learned that the SI unit of potential difference is the volt and an alternative unit is joule per coulomb. To measure potential difference, we can use an analog voltmeter, which is on our left, or a digital voltmeter, which is on the right of the screen. Here we see a multimeter which is being used in the voltmeter mode. Let us move to an exercise. In this exercise, we are going to write down the names of the physical quantities used in the equation. We will also write down their SI units. You got it right. V is the potential difference in volt. Q is the charge flowing in coulomb. W is the work done in joule. We have in front of us a simple question. The circuit shows two bulbs connected to a dry cell. The potential difference across bulb A is 3 volt. What does this mean? This means that when 1 coulomb of charge passes through the bulb A, 3 joule of energy is converted from electrical form to non-electrical forms. We now move to the second concept of our today's lesson, which is electromotive force, commonly abbreviated as EMF. We learned today that when we refer to potential difference, we refer to 2 points in a circuit. But when we study electromotive force, we shift our attention from the external circuit to the dry cell or battery used in the circuit. As we know, dry cells and batteries both contain chemical energy. When a unit charge passes through a cell or through a battery, chemical energy is converted to electrical energy. The work done during this energy conversion is known as electromotive force. Hence, the EMF of a cell or battery is defined as the work done when 1 coulomb of charge flows through the closed circuit containing the cell or battery. Mathematically, EMF is equal to work done divided by charge. Therefore, E is equal to W divided by Q. Let us apply the formula to a physics problem. A battery of EMF 12V is connected in a closed circuit. Calculate the work done when 3 coulomb of charge flows through the circuit. We are going to use our formula. E is equal to W over Q. Hence, 12 is equal to W divided by 3. After cross multiplication, W is 36, which means that the electrical work done is 36 joule. In this lesson, we learned that number 1, what is potential difference? Number 2, what is electromotive force? And number 3, what is the relationship between these two concepts. We hope you enjoyed this video. We thank you for your time and attention. Till next time, it's goodbye from us.